Hello everybody, this is going to be your pre-lab lecture for fractional distillation. I want to get started by giving you guys the dates that everybody is going to do this. So Group A is going to be doing this lab for the week of October 12th through the 16th, and Group B and C is going to be doing this for the week of October 19th through the 23rd. As always, read your lab manual, complete your pre-lab quiz. This is an in-person lab, so groups A and B, make sure you bring your pre-lab notebook to lab. Also, I wanted to add gas chromatography in the past semesters was not done with this lab. Basically, at the end of fraction distillation, you would save 3 fractions, and then you would test them the following lab in gas chromatography. But since COVID, we want you guys to get a little bit of experience with the GC, so we included the GC for this lab as well. So keep in mind you have to do your fractional distillation, and at the very end, gas chromatography analysis. Okay, so I wanted to mention really fast for your pre-lab notebook, make sure that you bring it into lab like I had just said. Also, Dr. Rastogi is granting an extra point for your complete notebook if you guys decide to illustrate your procedure. Basically, draw pictures of what is going on in your procedure. Okay, don't forget to do your pre-lab quiz for Group C. I want to add that I'm not sure if people are not sure of the dates, but your pre-lab quiz is due before every Wednesday at 8 a.m. regardless if you're online or in person. You have to turn in your quiz. If not, your participation points will be deducted. This is your setup for fractional distillation. I will go through this setup a little bit more in lab and a little bit in the PowerPoint, but more than anything, I will be helping you guys in lab. Okay, your post-lab notebook, like always, due before 11:59 p.m. every Sunday. This is going to be the data for Group C. Group A and B, do not use the data in Group C. You guys are going to be gathering your data in lab. Fractional distillation. Fractional distillation is a technique that is normally used to obtain each volatile component of a mixture in pure form. It is used to separate volatile compounds from one another if their boiling points differ by at least 40 to 50 degrees Celsius. I apologize because I didn't put the degrees, but keep in mind that when you guys did simple distillation, it also separated volatile compounds, but it differs in boiling points from fractional distillation. So make sure you know the difference from simple distillation and from fractional distillation. The fractional distillation process. I included a video here, but I'm probably going to have to link it when I make the announcement because I can't press it for you because then this presentation is going to be very long. So I might as well just link it for you, and if you guys want to go ahead and watch it, you can. So our column provides a vertical path through which the vapor must pass from the still pot to the condenser before being collected into the receiver right here. As the vapor from the still pot rises up the column, some of it condenses in the column and returns to the still pot. This is basically just rapid series of condensations and revaporizations. And these condensations and revaporizations are the same thing as doing a bunch of simple distillations at the same time. So, equilibrium between liquid and vapor phases must be established in a fractional distillation column so that the more volatile component is selectively carried to the top of the column and into the condenser, where the vapor condenses into the distillate. After all of the more volatile component is distilled, the less volatile one remains in the column in the still pot. The heat supplied to the still pot is then further increased in order to distill the second component. Okay, so all of this basically means is in your still pot, you're going to have a mixture of 2 components. So the component that has the lower boiling point is the one that is going to distill out into into the receiver. And we're going to put the temperature up a little bit more, and the second one is going to distill out as well. But keep in mind, the first one that's going to be coming out is the one with the lower boiling point. Okay, important requirements for performing a successful fractional distillation. This is in your lab manual. I just want to repeat it for you, that way you guys know it. There should be an intimate and extensive contact between the liquid and the vapor phases in the column. Filling the column with inert material having a large surface area will account for the extensive and intimate contact. Maintenance of the proper temperature gradient along the column, sufficient length of the column, sufficient difference in the boiling points of the components of the liquid mixture. The difference in boiling points between the two components should be no less than 20 to 30 degrees Celsius. Again, I did not the Celsius, so I'm sorry. The objectives for this lab. We're going to perform a fractional distillation to isolate 2-butanone and 2-pentanone. Procedure setup. Now, I am using this picture to show you guys how you're going to be doing your procedure. This does not mean you can plagiarize it. If you're going to draw your procedure for that extra additional point, you cannot copy this because it is essentially plagiarism. Okay, so we're going to start with adding 10 milliliters of 2-butanone and 20 milliliters of pentanone to a round bottom flask with 2 boiling stones. Make sure you put this mixture before you add grease because you can contaminate it if you add grease afterwards. This is going to be your setup. Now, we're going to first heat the mixture to 80 degrees. Everything that's going to be coming out is going to be up until those 80 degrees. Once you see that the 80 degrees deviate by about 3 degrees Celsius, then we change to receiver B. Receiver B is going to contain everything until it gets to 100 degrees. Once it gets to 100 degrees, we're going to change to receiver C. And we're going to keep heating at 100 degrees for receiver C. And once we see that our still pot has about 3 to 5 milliliters, then we are done, okay? We cannot let the still pot get dry. A fraction of 5 milliliters is going to be collected for receiver A, 7 milliliters for B, and 7 milliliters for C. So after this, we're going to collect small fractions in test tubes so that we can test it for the GC. It's going to be 2 milliliters in each test tube. After that, we're going to grab 0.2 microliters to put into the GC. I will explain more about the syringe while you're in lab. If you're in group A, by the time you watch this video, you already did this lab. But if you are in group B, I'll explain a little bit more about the syringe in lab. And then afterwards, we're going to print 3 spectras corresponding to the 3 receivers that we had, or the 3 fractions that we collected. Notes for lab, or something to keep in mind. We're going to be using rings for the packing. There is going to be a wet beaker ring and a dry beaker ring, so make sure that you guys do not throw these away in the trash. Make sure that you clamp properly. It's very important to clamp properly because your glass can fall and you can break it. So I think I have found a really good way for you guys to clamp everything, so I will be showing you guys that in lab. 2 pentanone, 2 butanone, and 2 boiling chips inside the pot before adding grease, like I said, to avoid contamination. You're going to add grease to only the upper portion of joints so grease doesn't contaminate the distillate. Now, you're only supposed to add a little bit of grease, so I'm going to demonstrate the first one, and then we can continue from there. GC analysis and calculation. I'm going to read all of this for you, and then I'm going to show you what it should look like calculation-wise. GC is reverse phase chromatography. The retention time is the unique time it takes for a compound to exit the column after it is injected. The lower the boiling point, the higher the vapor pressure of the compound and the shorter the retention time. So if you have a compound with a lower boiling point, it's going to leave first. And it is the same thing for the retention time. If it leaves first, it's going to have a shorter retention time. To determine the area for each peak, measure its height and width. The area of the peak is equal to half width times height. To determine the ratio of each compound in the mixture, add all the areas together to get a total. the percent composition of any compound in the mixture is equal to its area divided by the total area of all peaks in the sample. So I know this is probably kind of confusing, so I'm going to explain it to you differently. Okay. Excuse my handwriting. Okay, so let's imagine a spectra with two peaks. You're going to have peak A, and then you're going to have peak B. So to get the area of peak A, we're going to do half height times width, and you're going to get a value. Now you're going to do the same thing to find the area for peak B. Half height times width, and you're going to get a value. You're going to add these two values up, and it's going to give the total area for the peaks. Now, that is if you have two peaks in your spectra. If you have only one peak in your spectra, you're going to calculate the area the same way, half height times width. You're going to get a value. Now you don't have any other peak, so whatever that value is going to be the total area, okay? So for percent composition, your percent composition peak for A would be your area for peak A, which is what you calculate right here, this value, over your total area. So peak A plus peak B, and then you will multiply it times 100. Your percent composition for peak B is your area of peak B, this value, and your total area, peak A and peak B, times 100. If you only have one peak, then you only have to calculate the percent competition for that one peak. So it would be area for peak A, and then your total area. So you would have the same value on top and the bottom, and you multiply it times 100. Okay. I hope that wasn't confusing, and if it was confusing, let me know and I will explain it a little bit more through email or an additional Zoom meeting. Okay, and to end this video, what to include in your lab report. So for your pre-lab, post-lab calculations, the area of the peak and percent composition, that is going to be coming out of your GC spectrum, and then your percent recovery. For changes, there will be no insulation on column, and make sure to apply a small amount of grease to all your joints. Okay, so that is pretty much it for this lab. If you guys have any additional questions, please email me, and I'll see you guys in lab.